Welcome everybody, thanks for coming to this presentation. Will your program still be correct next year? I'm Björn Fahller. So, will your program still be correct next year? Or how to prevent evolution from taking the wrong turns? Because programs tend to evolve. When I'm not standing on stages at conferences, I work for Net Insight in Stockholm. We make networking equipment. Most of my career has been writing software for devices like these. That is not what I'm going to talk about today. However, what I am going to show you is, I'm going to drive this talk with an example with this hideously complicated program. It's a histogram of words, and I forgot to start my timer. There it's going. So we want to be able to insert words, remove words, ask how many times a word occurs, and be able to go over the range of all the words, and I'm storing them in a stud map. So we can implement something like this. I insert, try to emplace it. If it wasn't inserted, then just increment the counter. Remove, look it up, decrement the counter. If the counter became 0, erase it from the map. The lookup operator, find the word. If it was there, return the count, otherwise return 0. Pretty straightforward. And begin and just forward it to the underlying container. Okay, is this correct? Well, we can write a test, of course. I create an instance of a histogram, I insert a few words, I print the collection, remove a couple of words, print it all again, and check if the foo and buzz are there and how many of them. And I print them, and we see I inserted foo twice, we have foo in there. I inserted bar once, we have bar with the count of 1. Inserted baz once, baz is there with a count of 1. Yeah, that checks. Okay, good. Remove baz and foo, and we see that foo now has 1 and baz is no longer in the range. So, okay, that looked good so far. Print count of foo, it's 1. Print baz of 1 is 0. That is excellent. This is looking really good. And also, since we did print of the whole range, we have already exercised begin and end. So, yeah, nailed it. I've tested it. This is good, right? This is good. Is there a problem there? I would argue this actually comes down to the question: what are tests for? Why do we have tests? If the only reason to have a test is to ensure that the code I just wrote is correct, then I would argue that what I just did is perfectly sufficient. I demonstrated to myself that everything works. It's correct. But no one will know if a future change would introduce a bug. No one would run that program again and verify that everything is still as expected. So, okay, another attempt then. I create a histogram, insert a few words. I assert that these are the elements in the range. This is what we get. Okay, good. And the same after removing words, check them. And assert also the angle bracket operator for looking up. And we can run this and it passes. Now I have a good test, right? Check it in, run it automatically on every auto builds. We know that if we break something, we will be told. This test will absolutely expose that. I have totally written this kind of code in my life. Actually, I have totally written the previous one also. Yeah, you learn things over the years, you know? But I mean, sure, got it. This is right, this is good. Let's look at some different types of tests. This is just a few on top of my mind when I was writing the slides. There are many more, and also many tests go under different names in different places, so don't take these in any way as an exhaustive list. But there are some differences between them. There's a difference between an acceptance test and a unit test, or a fuzz test, or a stability test, or a stress test. They have different purposes. So let's look at some types to see, for example, first, why do we have these? What's the purpose of them? So the purpose of a fuzz test, I would argue, is to find bugs. That is why you do fuzz testing. Ad hoc test is manual fuzz testing. Acceptance test, verify compliance with requirements. Are we shipping the thing we should have shipped? Production tests, I work for a company that makes physical equipment. We need production tests. Unit tests, show that the code does what it's intended to do. Performance tests, ensure that performance meets requirement, or if you don't actually have performance requirements, at least monitor that your performance doesn't degrade. Stability test, run over a long time, find state degradation. Integration tests, find misunderstandings, where each team thought they did the right thing, when then put together, it doesn't actually work. Stress tests, give the software more to do than it is able to handle. What happens? Do we have the priorities right? Smoke tests, stop wasting time. Just a bloom filter to see if it's worth going on. So we can also look at who is interested in the results of these different tests. So for fuzz tests, it's definitely for the developer. Hey, you missed this corner case. Ad hoc tests for the teams, I would say. Acceptance tests definitely for the teams, but also for the product lead and for the customer, the client that bought the software. For the production test, it's a manufacturing plant to see that we don't deliver faulty equipment to a customer. Unit tests, unit tests definitely for the developer. Who is the developer? Food for thought. Performance test, definitely for the team, but also for the product lead to be able to see that, to be able to say to the sales and marketing people, we know that we have this performance because we are testing it, we are verifying it. Stability test, definitely for the team. Integration tests between several teams. Stress tests, usually between several teams. It's unusual to have a problem turn up that is local to only one team. Smoke tests also for several teams, I would argue, usually. And also, what is the desired outcome in case the tests fail? For fuzz tests, missed cases. Ad hoc tests, missed functionality or mismodeled couplings is a classic thing with a 70s car, when if you brake hard while you're tooting the horn, the windshield wiper goes on. Acceptance tests, identify misunderstood or missed requirements. Production tests, prevent shipping of defective products. It's a bad soldering somewhere or whatever. Unit tests, understand what is broken. Performance tests, identify performance bottlenecks. That's kind of obvious. Stability tests, find things like memory leaks or cumulative errors. I had a really fun cumulative error, a rounding error with stood chronotypes that led to a malfunction after 13.5 hours of continuous streaming of video. That was fun to debug. Integration test, identify misunderstandings between the teams. Stress test, find modeling errors when you're not properly handling which work you have to give up and which work you can accept. And smoke tests, we run them as, we have some really long tests that runs on whole networks, and they take many hours and a lot of equipment to do. So you have a quick smoke test to see if it is it worth starting this long test run or not. So there are some similarities. So I'm primarily focusing on unit tests in this talk, but much of what I say is applicable also to these tests, because there is something common between all of these. They all say what is not working as expected. So they pretty much have to say what the expectations are, don't they? So what's the problem with this? It will fail if we introduce a bug. That is good. But a failed assert leads to a detective work to try to understand what on earth is actually the problem. We just see that, yeah, okay, this assertion failed. What? What is it? What have we done? You have to read back from the sources and see what's the history up until this failure point. And what was the actual result? We don't know. We have no clue. And that is what we don't want. So we can, if you instead write your tests as a set of requirements or a set of propositions for functionality, then a failed test will always tell you what doesn't work. It's that thing that you stated. And the failure message will tell you the details about how the problem was found. So yeah, we can improve things ever so slightly. Have a number of sections. Each section begins with printing something that, what are we testing? A default constructed histogram has no words. We create a histogram, we assert that begin and end are the same, and if we haven't crashed by now, we print pass into the next section. When a word is inserted, it has a ref counter 1 with operator angle brackets. Print pass if we haven't crashed by then. And if we run it, we can see that we had a bug. Okay, what's the problem? What's wrong? When a word is inserted, it has a ref counter 1. Okay, interesting. How was the problem found? Well, h angle bracket foo equals 1 failed. That is not true. We have information here that limits the scope of our detective work. We know what's broken. However, don't do what I just did. Use a unit testing framework. Here are a few examples of some open source ones. Anyone use Criterion? I learned of this when I wrote these slides. I didn't know it existed before. No one? I'm disappointed. I've used the others to not much boost test, to be honest, but I have touched on it. There are also some commercial tools, if you, for some reason, prefer that. So, example, using doctest. Doctest is extremely easy to get started with. It's a single header file. You include it. If you have this hash-defined doctest config implement with main, it even makes a main function for you, so you don't have to do that. Every test is this test case and a description. The description is the name of the test. And then you write the test logic in each of them. The capital require is the assertions used in doctest to ensure that we have the result that we expect. A thing, advice, not absolutely necessary, but I think it's good advice. In your test files, always begin with including the header of the thing that you are tested as the first thing you include. Because that way you know that this header stands on its own merits. There are no hidden dependencies. Not a requirement, but good advice, in my opinion. So if something then goes wrong, what is wrong? Well, when a word is inserted, it has a ref counter 1 with angle brackets. Okay, we have a bug. We know what is not working. How was it found? Require h of foo equals 1 is not correct. It expands to 0 equals 1. So now we know that either insert does not increment the count as it should, or the angle bracket operator returns the wrong value. These are the only two errors we can have. This is good information. This is something we can work with. And quite quickly zoom in on the bug and fix it. So, more functions. We need a way to query the number of words in a histogram. That is, it's a reasonable thing to be able to ask. So let's add a size and empty function. Forward them to size and empty. By the way, if you have questions, just try to raise my attention and shout it out. We can take questions at the end also, but don't be afraid to interrupt me. Okay, so we can write some test for this. A default constructed histogram has no words. We require that h of begin is the same. The empty is true, that h of size is 0. This makes a lot of people very unhappy. And the reason for this is that a test case should test only one thing, which quite many developers have taken to mean that a test case should only have one assertion. Is that right or wrong? Personally, I'm fine with this, but there are some developers who I hold in very high regard who think that this is not okay. These should be 3 separate tests. We have different views, it's not the end of the world. Do what works for you. But the important thing is, don't test several. If you have several asserts, make sure that they are different ways of expressing the same logical thing, not wildly different other things. That would be horrible. So the question, I guess, in this is this one thing? In my opinion, it is. Some people disagree. Okay, so we work some more. We add some more tests. So given this is really a powerful thing with doc tests. You can have this given, when, then, and when, and then, and when. So given a histogram with 2 unique words, the size is 2, and when adding a word that already exists, the size is still 2, and when adding a new word, well. And this style is super powerful when you want to do a series of tests sort of around a common theme with a common starting point. This is useful, but beware. There is a very human temptation to just add more, and when, and when, and then, and when, and then, and then, and when, and then, and when, and then you suddenly have a test case that is 1,000 lines long. And it's absolutely impossible to navigate. Please do not fall for that temptation. Constrain yourself. When you see that the test grows, stop and think, what am I doing? Reflect. Not language reflection, your own reflection. So, with this, something obviously went wrong. What? Adding a word effect size, a histogram with 2 unique words, and when adding a new word, the size becomes 3. Okay, that was odd. How was it found? Size equals 3 is not correct. Require 2 equals 3. Okay. So it seems like the word wasn't inserted. Interesting. This is super powerful. So we add some more tests. We insert a bunch of words, and we check that all of them, the whole range of words is what we expect. So include foobar, foobaz, banana, baz, and then we use required to see that the range is equal of our histogram range and the expected are the same. And I mean, it's not incorrect, but there's not a lot of information. I'm not happy with this. I'm bravely changing to another unit testing framework, Catch 2. Catch 2 and doc test. For simple tests, the test sources will look exactly the same. But catch 2 has a bunch of matchers that are useful for these things to match ranges, for example, of values. So here we can check that I use catch matchers range equals and see that our range is equal to the expected. And that is useful. So now I can run it and man. I mean, we can at least see that they are the same size. Okay, what happened here? They seem equal to JSON. Yeah, I agree, but it's I'm not happy with that. What went wrong?
For your custom item.
I need a matcher for my custom item. No, that is actually not it. I don't need a matcher. Sorry, again? I need to know how to print the type, print the object. So in this case, both of these ranges, the elements are stood pair of string view and a size t. And there is no default O-stream insertion operator, because that is what catch 2 uses by default to print something. It uses the O-stream insertion operator to print the elements. Do not fall for the temptation of writing O-stream insertion operator for pair. Don't. Just don't. Instead, catch 2 has a way of saying that even if there was an O-stream insertion operator for pairs of string view and int, we can say that no, for the purposes of the test, this is how I want to print these. This is how I want to visualize the value. So you make a specialization, or in this case, a partial specialization of catch string maker, pair of t and u, and I have chosen to print them as curly bracket, the first, comma, the second, and curly. That is how I want to represent pairs in test. So when I do that, now I got the information I wanted, and I can see that I have a really weird bug in my implementation, that everything else works, but Baz has the wrong count. But this is something to work with. Now you can figure out what your problem is. This is an easy trap to fall into, leaking implementation details. So we need to improve performance. This is not good enough. Stud map is horrible. It's a balanced tree. Every lookup, it has to search through the nodes to find it, and every insertion and removal, it has to rebalance the tree to make sure that you keep the sort order of everything. So it's and ensure that the height of the tree is balanced. It doesn't get awfully skewed. That is a lot of work that is not necessary for this histogram. So why not change it to unordered map? And I use now a specific transparent string hash so that we can hash everything that works as a string, like std string, string view, a C string, const char star. They are all hashed the same. So this really should work, shouldn't it? This would be so much faster. So we test this, and damn. I mean, I have all the right things, but the order change. Okay? Well, the test is over-constrained. We have never said anything about the order of the elements. Do not go and change the expectation to be this order. Don't. If it has changed once, it will change again. You will use some other underlying container instead for whatever reason, then it will fail again. The problem is not the specific order. The problem is that you have specified an order. So back to catch 2, we can change this to another matcher, unordered range equals to say that the range H must contain exactly these elements, no more, no less, exactly these, in whatever order. Another test passes. Good. And now we are safe for future changes. If you change this to a flat map or whatever, then this test will still pass. Unless, of course, you introduced a bug that these are not the correct elements. Much better. Don't over-constrain tests. It's super easy to make that mistake. It's, of course, better if you think about it beforehand, but if it happens that you make this mistake, just ensure that you correct the mistake instead of making the same mistake again, but with another set of elements. Okay. This one's funny. I think I'm going fast. You're not asking a heck of a lot of questions. So, new requirement. We need to be able to insert and remove words in a long string. The words are separated by some substring. Okay. So I have insert string view, the long string with some separator, and I remove string view with some separator. Okay. We can see quite easily that obviously we need both for insert and remove, we need some way of getting the sequence of substrings and do either an insert or a remove of them. That is obvious. So we can write something like this. It's private because it's absolutely nobody's business how we do this. So we keep it a private function. And I can implement this logic where it takes the words and the separator and some action to call. And some hideous logic here. But call action for every substring that we find. And then insert becomes just per word, pass the long string and the separator and a lambda that does an actual insert of this. Okay. But the question turns up, how do I test something that is private? This is something that took a very long time for me to understand. I was constantly very confused. Oh, thank you. So it's like, I asked someone more senior, like, how do I test private logic? And they said, you don't. But surely there is a lot of quite elaborate logic in here. I have to test this. Yes, I agree. You absolutely have to test this. But how do I test private implementation? You don't. What? What? It took ages for me to get this. What you do is you move it out. You move it out somewhere else as a freestanding class, or in this case, a freestanding function template. And you test it, ensure that it works correctly the way you want it to, and it's a private business that you are using it. Man, that took time for me to understand. So sure, we make this new function template per word. Sorry?
First as well. Why are you testing private functions? Surely if you exhaustively test your public interface, that will take your private functions with them.
Despite the microphone, I actually didn't hear what you said.
I asked, why are you testing your private functions? Because surely if you exhaustively test your public functions, then all your private functions will either be tested or will be redundant.
If I'm not testing my private functions, they are either untested or redundant. I disagree. They can be simple enough that you don't have to test them per se on their own. You ensure that your test of the public functions does exercise the bits that you need. But I will come to this in a few slides. So I have this freestanding per word function template. When it's on its own, it's may be obvious that the name is not great. This is less not great. But yeah, for each word, I think that is reasonably possible to understand what we mean. And we have this logic, and I can write some tests. Action is called on each substring between separators. We have a vector of substrings. We call for each word on A, CD, no B, because something. EFG and comma as a separator, and the action is to just push back the substring. And then we require that the substrings range equals this array A, CD, EFG. Note range equals here, not unordered range equals, but because here we actually really want the order. And then we add a bunch more. Action is called on the whole string if separator is not found. If the string ends on separator, an empty string will be the last. If string begins on separator, an empty string will be the first. Adjoining separators yield empty strings. Action is never called if separator is an empty string. Action is never called if the string of words is empty. All right. This is powerful, because anyone who has the function signature for this function template and just the names of these tests will know what to expect. So back to my histogram. And now I'm using for each word. In this case, I actually don't have a private function. So, but if this was more elaborate, if instead of for each word, it was a class that has some member function that for various reasons sometimes returns values from an enumeration, say, I want to ensure that I have tests that triggers all the cases, all the reasons, all the actions that depends on the different returned enumeration values. But I don't have to test every corner case of that function here. I test that I react properly to what it responds, to my request to it. So also in this case, I write the tests that are interesting from the purpose of the functionality of the histogram. I don't have to trigger every corner case of for each word, because that is covered elsewhere. Okay, so time passes. You browse through CPP reference as one does, and you suddenly find split view. Okay, split view takes a view and a delimiter and splits a view into subranges on the delimiter. That sounds suspiciously familiar. I wonder if we can do that. Maybe it would actually make things easier. Let's give it a go. That looks quite nice. I like that. Let's test it. Oh, something is wrong. What is wrong? For each word does nothing if separator is an empty string. How was it found? We got every single character. This is information. We can use this. It's quite obvious what happened. The difference between the implementation I showed and the ranges implementation is that the ranges implementation says that if the separator is nothing, then you get each single individual element. In this case, each single individual character. So, simple fix. If separator is empty, return. We're done. We have replicated the same functionality. Test passes. Saved by the test. Good. So, who has heard about contracts? Did you listen to Timur's talk? Yeah. Let's imagine for a moment that we are not living in the future and we have to solve problems with the tools we have today, which I guess shouldn't be very hard to imagine. How do I test that? Because this is a precondition. But if we don't have contracts in the language, how do I test this? Well, one thing we can do, I can bravely change to another testing framework. I'm using Google Test. Google Test differs a bit from the other two I have showed. So tests are written like this: test, comma, test suite, and test case name. And both the test suite and the test case name must be valid identifier, because the code generation from this macro expansion actually becomes classes and functions with these names. So the formatting is a bit ugly, but it works. Google Test has this morbidly named thing called death tests. So I can assert exit that when I remove banana, which is absolutely not inserted, we ensure that this thing dies on SIG abort. And it does this on Unix-like systems like Linux. It does this by forking the process running this exact thing and then monitoring the exit code from it. I don't know what it does on Windows. It is in the description, in the documentation, but I forgot because I'm not a Windows developer. But it is available on Windows too. So I can run this, and here is a failure message from Google Test. What's wrong? Removing non-existing word is illegal. How was it found? Died, but not with the expected exit code. Terminated by signal 11. Wow. Zigzag. Okay. That was indeed unexpected. But this is actually really powerful. This is useful, I think. The downside, perhaps, of the death test is a lack of granularity. If the function would have several asserts, you have absolutely no clue which one fired. But otherwise, yeah, it's not too bad, actually. It's useful. But if was there a question? Okay, no. If we're not, for whatever reason, if we cannot use Google Test, what other ways do we have? So I guess I could use a mock here. Mocks are really interesting. There's such a division between programs. Some say mocks are the absolutely worst thing ever invented. If you ever use one, you're an idiot or shouldn't be doing programming. Others say, of course I use mocks. What are you talking about? It's the most natural thing in the world. And I can say, historically, 10 to 4 or so years ago, I used mocks a lot in the code I wrote, in the tests I wrote. Then, for the next 4 or so years, I didn't use any mocks at all. And for the last year, I did, again. Does this mean that 5 or so years ago, I finally saw the light, I knew how to write tests, and then I totally lost my marbles last year and regressed mentally in the most horrible way? I don't think so. I think it's a matter of what kind of software you are writing. Now, I am the author of a mocking framework, so maybe I'm not totally neutral on this topic, but I think there is definitely a place for mocks, and that is when you have software whose purpose is to collect information and distribute it to several receivers, and especially if the order of these are important. And now some functional smart arts comes up and says, but if order is important, then your software is incorrect. It should never matter. And I say, that is very nice, but reality doesn't work that way. If you're telling a piece of hardware to do something and then power off, you really better do them in that order. Otherwise, it doesn't work. But I do find that mocks are extremely overused, and that makes me very sad. I've even heard developers talk about how to model their software so that they can mock it. And that is extremely backwards. Think about what you want to solve. And if that then matches naturally into mocks, then by all means use mocks, is my opinion. There are definitely people who are going to write hateful comments on YouTube for that. And also, how does the software get access to the mock? The mock will be a test replacement for something that would otherwise call abort. How do I get to it? One method is to use factories where you say that here is the replacement to use. Another is to not use factories, but to parameterize it. So should we give the mock as something in the constructor to histogram or as a parameter to remove? I don't know. And if we're not using a mock, what should we do then? We could use a function. Just a plain function pointer or a stud function or function ref. So that is in the standard now, isn't it? I think it is. Personally, again, from my own experience, I used to use factories a lot. I don't anymore. I thoroughly hate factories. They make the software difficult to follow, I think. So I guess it's personal preference to some degree, but I find it that they make the software more difficult to understand. So I prefer to parameterize. So I introduce a precondition function pointer type, which is misnamed, I realize. It should be a violation handler or something. That defaults to my default handler that just calls abort. And then I can change this assert to be if the iterator returned was the end iterator, then call the violation handler. Pretend it says violation handler. So one way of testing this, if you don't have death tests, is, for example, to do something that could never happen otherwise. So here, back to catch 2 here, I introduce a new exception class that exists only in the scope of this test. And I use my replacement violation handler that throws this specific exception. And then catch 2 has this require throws as, and I say that when you call h.remove banana, this lambda, the result must be that it throws an instance of test exception. And in this case, something is wrong. Remove a non-existing word is illegal. It didn't throw. Okay. This is information. But the advantage of doing something like this is, especially with have a local exception class that only exists here, there is absolutely no way this same exception can be thrown in by any other means than by calling my the test violation handler. This is useful. But what about that one? As this is implemented, this calls remove for every word, but if there are words in there that aren't legal to remove, how should I do that? And I think this is also one of the things where you have reason to pause and think. This is hard to express in a test. This is often a hint that something is not quite right with your code. Something is more difficult than it needs to be. There's reason to take a few steps back, think, should I maybe have modeled this in a different way? Is there some other way I can do this? And yeah, maybe we should say that actually it is legal. You can do this. We just return the number of actually removed words. That is one way of doing it. And then the caller can decide how they want to deal with that. Maybe. Or yeah, we write some more tests. Removing a word not in the histogram 0 is return. Removing a word in the histogram 1 is return. Removing multiple semicolon separated words, etc., etc. Something is wrong. Removing multiple semicolon separated words, the number of existing words that were removed is returned, and we see that it's the wrong number. Oh, okay. But actually, maybe we should rethink. Maybe this whole idea of these remove and insert that takes a long string and separators was a mistake. Maybe we shouldn't have had these at all in the histogram class. They don't belong there. Maybe we should say that it's up to the user of the histogram to iterate over the words through whatever means they like. For example, there is this handy function called for each word. Maybe the user code should be to iterate over the words, and this is one example of how you could deal with it. There are others, but now we have left the decision to the user of what makes sense for them. I think this is actually the preferable thing. But the message here is just, if it's hard to figure out how to test something, maybe your model is wrong. Stop to think. So, wrapping things up quite early, as it seems to be, a good test, in my opinion, tells you what is wrong by telling you what right would be. And a good test works as documentation that is automatically verified on your auto builds every single time. A good test suite is a set of very simple tests. There can be many of them. There can be very many tests, but each test is simple, easy to understand. And listen to your code. If it is difficult to express a test, it's your code's way of communicating with you and saying something is problematic here. Maybe you should do something else. Beware of dogmas. There are so many dogmas around testing, and specifically unit testing. You should write one test for every function. One? For every? A test should only test one function. Okay, so no constructors, I guess. A test should only have one reason to fail. Again, no constructors, because if the constructor fails, then every test fails. But a test should only test one thing and report one problem. Yes, I agree. That's good. So beware of the dogmas, but many of the dogmas serve as really good guidelines. So don't take them literally, but yeah, they are worth paying attention to see what should I do? Don't write tests that, yeah, I was nearly saying youth, but that is absolutely not correct. In my early days of unit testing, I definitely had tests that tested like 20 different things in one single test case. Don't do that. And also, don't sweat it. A bad test is absolutely superior to no test. I had reason to go back to and fix a bug in code I wrote about 10 years ago. And it has really good test coverage, and the tests are absolutely awful. But I made the bug fix, I ran the test, and I had accidentally introduced another bug, and it was caught by this. Now, the tests were horrible, so it took a couple of days for me to understand what the problem was, but it prevented me from shipping a bug. So a bad test is superior to no test. I had reason to go back to code I wrote 20 years ago. That was not a fun experience. The functions were 500-600 lines long. That was compensated by having identifiers that were typically 2 or 3 letters. And of course, the variables were reused several times for different purposes. And not a single test, not one. That was not fun. Now, I really don't like making changes to test to code that doesn't have tests. However, do not ever accept flaky tests. By flaky tests, I mean tests that maybe usually passes, but sometime now and then it fails for some spurious reason beyond your control. Just don't accept it. Either fix the test or remove it. Preferably fix it. Because what happens if you have flaky tests is that you stop listening to that test. It's like, yeah, it failed, yeah, but just rerun it. Okay, yeah, rerun it. No, it worked. Okay, fine, good. And then you're tired of this test stopping your auto build. So you, in your CI pipeline, you mark them as may fail, which means that from this moment on, no one is going to listen to this test. And now you make a change that introduced a bug that this test actually catches every single time, and no one knows. Nobody cares. No one sees it. Because it's may fail. Everybody knows that. Yada, yada. Fix it or remove it. Because when you are in the may fail state, you essentially don't have it. It just takes a little time. Software tends to evolve for much longer than you think. Much longer. So your tests are not there to just verify that what you just wrote just now is correct. Because if that was the case, then my first example would have been perfectly good enough. The tests are there to ensure that the software stays correct as it evolves. Like I said, I have made changes recently to code I wrote 10 years ago and 20 years ago. And changing the 10-year-old code was not great, but a lot better than the 20-year-old code because I had tests and the tests saved me. I want to finish by giving shout-outs to some other speakers. Kevlin Henney has done a bunch of talks with names sort of with variations around programming with guts. Guts is good unit tests. The first one I watched on this was from some Java conference, I don't remember when. For me, there is a clear before and after having watched that talk. It completely changed how I think about writing tests. Strong recommendation. I'm not sure which version is the best. I just grabbed that one more or less randomly. Our conference organizer, Phil Nash, had a bunch of test talks, rewiring your brain with test-driven thinking. And it's a really good talk that its aim is not so much on writing tests themselves and how you write tests, but it's about TDD, how you let the tests drive your software development. And it's really useful, and it also actually maps into both Kevlin's talk with the programmer with the guts and also what I presented here now. Because when you are letting the tests drive the development, your tests almost automatically tends to become better. Because you're thinking about, I want to add this functionality, therefore I write a test for this functionality and implement it. And now I write a variation on that functionality. So I write a test for it and implement it. So that is a good one. Arne, who is sitting here, had a number of talks called Properties of Unit Tests in C++, where Arne focuses on things to think about, things that are important to avoid, actually, and also things that are important to include when you write tests. So try not to test. This is a fallacy among beginners with tests, it's so easy to fall into the trap of testing the implementation instead of the expected behavior. So there are such examples. There are many examples in these talks. So strong recommendation to watch that. And That was Will Your Program Still Be Correct Next Year? Thank you. Here is the link to the talk if you want to have a look at the slides. Thank you very much.